Okay, so in this lesson, we're going to look at a strategy for factoring polynomials. So if you recall in our previous lessons, we talked about different types of polynomials, some where we had the leading coefficient being 1, some where we had the leading coefficient being something other than 1, some where we had the GCF, some where we had to use grouping, and then we also talked about special factoring. So in this case, we're going to put all of that together. And so that's going to be a strategy for factoring polynomials. Now, you have this in your Canvas course, so it's one of your files. So remember, the first thing you always want to do is to factor out the GCF, factor out the greatest common factor. That's the first thing. Then you look to see how many terms you have. If you have 2 terms, so if you have 2 terms, then you want to check and see if it's the difference of 2 squares, the difference of 2 cubes, so sum of 2 cubes, and then the sum of 2 squares. Remember, the sum of 2 squares you cannot factor. If you have 3 terms, a trinomial, then you want to see, is it a perfect square? Remember, a perfect square has the form a squared plus 2ab plus b squared, and can be factored as a plus b squared. Factor either by grouping or trial and error. If there are 4 terms, then remember we did grouping. And then always check each factor to see if you can factor it further. And if you can, then go ahead and factor again. And then you want to make sure that when we factor, that we factor completely. All right. And number 6, if none of the above applies and you've exhausted all possibilities, then the polynomial can be factored. It is irreducible, and we just say it's prime. Okay. All right. So let's go ahead and look at some problems dealing with this strategy. Okay, so number 1, we have 4x squared plus 24x minus 64. Now remember, the first thing you want to do, if you go back to our handout, first thing you want to do is look to see if we have a GCF that's other than 1. And so if you look at all 3 terms here, this trinomial, if you look at all of these 3 terms, you see that the GCF is 4. So we can factor out a 4. So the first thing you want to do is factor out the 4. And so when we do that, we get 4 times x squared, and then 4 times 6x is 24x, and then 4 times a negative 16 is negative 64. Okay? Then the next thing you want to do is see if you can factor this trinomial that's inside the parentheses further. All right, so you go off to the side, and you would rewrite it, and you would check to see if you can factor this further. All right, so remember, you're going to either use trial and error or use the AC method. It's up to you. But this one's easy enough to where we can just quickly just use trial and error. So x times x is x squared. If you look at the last, that's a negative 16. So remember, if the last sign's negative, that means these signs in here are different. So one's going to be positive, one's going to be negative. And there are several possibilities for 16. There's 8 and 2. There's 4 times 4. There's 16 and 1. So let's try 8 and 2. Looks like 8 and 2 would work. So we're going to put 8 here and 2 here. Okay. Now, you want to always check to make sure that what you have is correct. So just because, remember in our discussions in lessons, just because you've filled in these 2 binomials doesn't mean it's still correct. So you got to double check. You could have made a mistake with the signs or with any of the terms inside these parentheses. So the outer, you have negative 2x. The inner is 8x. And look, when you add them up, you get 6x, which is what you wanted. So therefore, I could have factored this further, and so you want to factor completely. So remember, always make sure you factor completely. Okay, so just because you factored out the GCF doesn't mean you're done. You got to make sure that this factor right here is factored completely. And so that's what we're doing here. So therefore, the answer is going to be 4 times x plus 8 times x minus 2. All right, and again, just as before, it does not matter whether you put x plus 8 in front of x minus 2 or x minus 2 in front of x plus 8. But again, remember, we always tend to put the monomial factor first. Okay? All right, number 2. Number 2, let's suppose we had negative 36x cubed plus 60x squared plus 75x. All right, so that's 75x. And so again, you want to go through these steps. The first thing you should always do is look for GCF. So if you look at number 2, and remember it's in standard form, it's in descending order, so always look for that as well. Sometimes it does help. It helps quite a bit if it's in descending order. But remember our discussion in the past that when that leading coefficient is negative, we tend to just go ahead and factor out a negative GCF. So in this case, if I look at this, my GCF will be a negative because my leading coefficient is negative. And I know there's an x in all of the terms, so I know I'm going to factor out an x, and you always use the one with the smallest exponent. So notice I have 3 factors of x here, 2 factors of x here, 1 here, so I'm going to factor out just 1. And in terms of my coefficient, negative 36, 60, and 75, the greatest common factor of those 3 numbers is 3. So I'm going to go ahead and factor out a negative 3x. That's my GCF. So then when I do that, I get negative 3x. I get negative 3x times, this is going to be negative 3x times 12x squared is negative 36x cubed. Negative 3x times a negative 20x is a positive 60x squared. And then a negative 3x. And remember our discussion in the past, when you factor out a negative, always be careful with these signs. A negative 3x times a negative 25 is a positive 75x. All right, now, just like we did here, go and deal with this on the side. See if you can factor this further, because remember, you got to factor completely. So I'm going to go ahead and rewrite this. So I get 12x squared minus 20x minus 25. All right, and then I'm going to go ahead and see if I can factor this as 2 binomials. I'm going to go ahead and use trial and error. And so for 12x squared, there are several possibilities. Let's go ahead and use 6 and 2. So 6x and 2x. And then for 25, let's go ahead and use 5 and 5. And remember, the last sign's negative, so that means these signs in here are going to be different. All right, so let's say plus negative. Now again, just because you fill this out, you got to check it. It may be that the signs are incorrect. It may be that instead of using 6x and 2x, I use 4x and 3x instead. So things like that. So the same experiences you've dealt with in the past. Okay, so let's check this. 6x times 2x is 12x squared, so we're good so far. So remember, using trial and error. So far, f is okay. Then a positive 5 times a negative 5 is a negative 25, so my last is okay. So then again, remember, you got to check to make sure I get that middle term, and so that's where the outer and the inner come into play. So if you look at the outer, 6x times a negative 5 is a negative 30x. The inner, 5 times 2x is 10x, and when I add them up, I get a negative 20x, and that's what I wanted. So so this right here is correct. So I get negative 3x times 6x plus 5 times 2x minus 5. So again, just remember, it's based on previous lessons as well. Don't forget that when you write your answer, you got your GCF is part of your factorization, because you're factoring the original. Don't say that's the answer, because that's what you've done here was factor this, which is part of this. Okay. All right, so be very careful. And again, always make sure you put the monomial factor first. Okay, number 3. Number 3, we have 18x squared plus 47x, that's 47x, plus 5. So 18x squared plus 47x plus 5. So if you look at those 3 terms, the GCF is 1. And this is an easy kind because they're all the signs are positive, and my last term is prime, so it's going to make things a little bit easier for us. So I'm going to go directly to 2 binomials and see what we get at that point. So there are several possibilities for 18x squared. There's 6x and 3x. If you want to try that, you can. Okay. Now remember the last sign's positive, so that means that these signs in here are the same, and they're going to be that middle sign. So that's one of the discussions we've had before. And then for 5, the only possibility for 5 is 5 and 1. So I'm going to go ahead and put 5 here, 1 there. Okay? So I'm just using trial and error. Okay, now remember though, you got to check this. So don't think that's correct. It may be incorrect. So let's check. So we're going to do the F first. 6x times 3x is 18x squared. That's what you wanted. So far, F is okay. The L, 5 times 1 is 5. That's what you wanted. Now let's check the out and the inner, because we want to make sure we get that 47x. So the outer, that's 6x. The inner, 5 times 3x is 15x. But when I add them up, I get 21x, and that's not what I wanted. So remember, 5 is prime. So switching those is not going to help, because if you put 1 here and 5 there, notice what happens if you do that. So if you switch to 5 and the 1, notice what's going to happen. This becomes 18x, this becomes 3x, and then you get 21x still. Okay? So let me make sure I did this correct. That's 18. I'm sorry, 6 times 5. I'm not sure why I said 18x. That's 30x, right? Okay, 30x. And that's 3x, so that's 33x. All right, so that's not what you wanted. So maybe then let's use a different set of factors for 18. So let's say 9 times 2. Let's try 9 and 2. So I'm going to go ahead and do that here. So if I do 9 and 2, I get 9x and 2x. And then again, the last sign's positive, and so it'll be the middle sign here. And let's go ahead and put the 5 here and the 1 there and see what happens. All right. So when I do the out and the inner, remember I'm checking to make sure I get that 47x. So when I do the out and the inner, 9 times x is 9x, and then 5 times 2x is 10x, but when I add them up, I get 18x. So that's not what I wanted. So let's switch the 5 and the 1. Okay, so here's the idea of that trial and error. So if I do the 5 and the 1, if I switch those, instead, I get, remember, just because you fill this out doesn't mean it's correct. You got to check. You got to make sure you get this back. So using FOIL, so 9x times 2x is 18x, so my F is okay. And then the last, 1 times 5 is 5, so that's fine. Okay, now all I got to do now is just make sure I get that 47x, which I use the out and the inner for that. So the outer, 9x times 5 is 45x. The inner, that's 2x. I'm going to add them up, I get 47x, and that's what you wanted. Okay, so therefore the answer is going to be 9x plus 1 times 5x, I'm sorry, 2x plus 5. Okay, and again, multiplication is commutative, so it did not matter whether you put 2x plus 5 as the first factor or 9x plus 1 as the first factor. It does not matter. All right, number 4. So let's look at number 4. So number 4 we have, all right, number 4 we have 49x squared plus 47x. Oops, sorry. Let me go ahead and rewrite this. 49x squared minus 28xy, and then plus 4y squared. Okay, so 29x squared plus minus 28xy plus 4y squared. Okay, so again, if we look at our little flow chart, our strategy. So first thing you look for is the GCF. In this case, it's 1. So the GCF here is 1. So then you look to see, well, first of all, are there 2 terms? No. There are how many terms? 3. So I'm going to skip this part. Are there 3 terms? Yes. So what I want to do, though, is just kind of focus again on what we've learned. So many students, when they get to the 3 terms, they tend to forget about the idea of that perfect square. But I want to focus on that because that's important. You know, why is a trinomial considered a perfect square trinomial? All right, so here's the idea. So look at your first term. Do y'all agree that that first term right here, I can write as a 7x squared, because 7x times 7x is 49x squared. And then the last term, I can write as 2y to the second power, right? And so if you look at this, that's that a squared and that b squared. So I'm squaring something and I'm squaring something. That's what that is. this part and this part. Now, this is actually a perfect square trinomial because look, the middle term says this. If I were to multiply what's inside those parentheses together, so 7x times 2y, and I get 14xy, okay? And then if I double that, do I get that middle term? Yes, you do. That becomes 28xy. So this is a perfect square trinomial. And what that means is this. What that means is if you can recognize as a perfect square trinomial, then you can get the answer real quick. It's just going to be a binomial squared, a binomial times itself. And it's going to be those terms that's inside the parentheses. So 7x times itself is 49x squared. 2y times itself is 4y squared. And all I need is that sign, this sign here, to be this sign here. And there's your answer. So 49x squared minus 28xy plus 4y squared, I can write as 7x minus 2y squared, or I can write as 7x minus 2y times 7x minus 2y. All right. And again, just before you go on, just double check. Make sure that what you have, if you check it, you get this back. So look, if I foil, I get 7x times 7x is 49x squared. A negative 2y times a negative 2y is a positive 4y squared. And the outer is 14xy, which is what we had here. And there are two of them, right? I'm sorry, negative 14xy. And the inner is a negative 14xy as well. So hence the idea of two of those. And when I add them up, I get negative 28xy, which is what you wanted. Okay? So this is a perfect square trinomial. Now, many students, they don't look at it that way. They just go ahead and use trial and error, and they factor. And that's fine. But there are some questions in which they're going to ask you about the terminology of a perfect square trinomial. And so that's, if you go back to that lesson previously that we did with that, that's where this was discussed. Okay? All right, so number 5. Number 5, we have 27x cubed plus 1,331. So 27x cubed plus 1,331. Okay, so again, if you look at your strategy, first thing you want to do is factor out the GCF. So if you look at this, the GCF here is 1. All right. So the factors of 27, you may say, well, how do you know it's 1? 1,331 is a big number. Well, you could use your calculator and check. So for example, what are the factors of 27 besides 1? Well, it's 3. Will 3 go to 1,331? 1,000, use your calculator. Divided by 3? Nope, because you don't get a remainder 0. 9 goes into 27. Well, 9 goes into 27, right? So that means that it knows that 3 goes into 9. So if 9 went into here, then that means 3 goes into here. So 9 won't go either. And you could check it. 1,331 divided by 9. Notice you get this number that has a remainder. And so 27 as well. So if you do 1,331 divided by 27, notice you don't get a remainder 0. All right, so the GCF is 1. So now let's look at what we have. How many terms do you have? You have 2 terms, right? So it's going to be one of those. So we're going to try one of those. And again, if you exhaust all possibilities, then you just say it's prime. Okay, so notice, remember, if you're going to have the difference of 2 squares, then you better have that exponent here being a 2 or a 4 or a 6. It better be even, okay? Notice that this exponent's odd, and it's a 3 at that. So let's go ahead and see if this is the sum of 2 cubes. All right, so remember what we did to determine that. So if we have the sum of 2 cubes, then we should be able to fill in these parentheses. So if this is the sum of 2 cubes, then it should look like this. And so you ask yourself, well, what times itself 3 times is 27x cubed? Well, 3x. because 3x times 3x times 3x is 27x cubed. And then you ask yourself, well, what times itself 3 times is 1,331? All right, well, that I'm not even going to guess at. So just use your calculator. Take the cube root of 1,331. Okay, so on your calculator, you should have see right here, you can't see it, but it's right here. So it looks like this, the x root. Okay, so that's so we're going to take the cube root. So you're going to say 3. You're going to say 3. Then you're going to say second this button right here. So hence that means the cube root you're taking of, and then 1,331, and then press equal, and you get 11. So the cube root of 1,331 is 11. So 11 goes here. So hey, this is the sum of 2 cubes. So then you got to remember though, what is the formula for the sum of 2 cubes? Well, remember that here's the formula right here. So the formula for the sum of 2 cubes, it's a binomial times a trinomial, okay? And so the way we learned it was this way. So let me just go ahead and write it like this. So we remember this is the way we learned it. So we had f cubed plus L cubed, so something cubed plus some expression cubed will equal F plus L times, so it's kind of like first and last. So that's the way we learned this, first and last. So it'll be the first plus the last inside the parentheses times the first squared minus the first times the last, and then plus the last squared. Okay, so that's the way we learned it. So that's your formula. So remember, this is your F, this is your L. So the answer then will be F plus L, so that's 3x plus 11. 3x plus 11, so there's my binomial. Okay, so remember the difference of 2 cubes, the sum of 2 cubes is always a binomial times a trinomial. And if you're doing this correctly, that trinomial should not be factorable. Just don't try and factor it. You're done. Okay, so then the next thing you do, remember you got to, the first term of the trinomial is where you take that 3x, take the 3x and you square it. So that's this right here. So that becomes 9x squared, okay? And then minus, and then the second part here is where you take the first and the last, and you multiply them together. So 3x times 11 is 33x, so that goes here. And then L squared is your last term, so it'll be plus L squared, so that's 11 times 11, which is 121. All right, and there's your answer. You're done. Okay, so that, now again, if you may need to go back and review the lessons previously that dealt with the sum of 2 cubes and the difference of 2 cubes, and you'll see where we talked about that idea. Okay, so that was number 5. Let's look at number 6. All right, number 6. In number 6, we have a negative 75n cubed plus 27n. So negative 75n cubed plus 27n. So it's in descending order, and the GCF here is, it looks like it's negative. Remember, always factor out the negative GCF if the leading coefficient is negative. So the GCF is going to be a negative, and it looks like 3n. Is that correct? Yep, negative 3n. Okay, so I'm going to go ahead and factor out the negative 3n. So remember, always follow your guidelines right here. Makes things a lot easier to do that. And so I get negative 3n times negative 3n times 25n squared is negative 75n cubed. Now remember, when you factor out a negative, GCF, always be careful with your signs. A negative times a negative is a positive. And so a negative 3n times a negative 9 is positive 27n. Okay, now remember, don't stop there. You always got to look at that second factor right here if you can factor that further. So if you think about it, I'm going to go ahead and rewrite it over. If you think about it, how many terms do you have? You have 2 terms. Okay, so is it one of these right here? Here it is. You should be able to recognize this quickly, right? Isn't that the difference of 2 squares? So in other words, if this is the difference of 2 squares, then I should be able to fill these parentheses in. So what times itself is is 25n squared? Well, 5n. And what times itself is 9? Well, that's 3. So it's the difference of two squares. And so remember the formula for the difference of two squares, and again, the way we learned it in the lesson was if I wrote this as f and L, so f squared minus L squared, then it's just f minus L times f plus L. Okay, so the terms are in the same order, except the signs are different. All right, so the difference of two squares. So basically this right here becomes 5n minus 3 times 5n plus 3. All right, and so your answer to the original problem then, don't forget your GCF, so your answer to the original problem would be negative 3n times 5n minus 3 times 5n plus 3. Okay, and again, always double check, FOIL this out, and you'll see you'll get this binomial back. So for example, if you FOIL it, 5n times 5n is 25n squared. A negative 3 times a positive 3 is a negative 9. And when you do the out and the inner, they should cancel out because you don't have an n term here. So notice that you get 15n, negative 15n. Those are opposites. When you add them up, you get 0. Okay? All right, so that was number 6. So that's your strategy. You just go through and you look at what you've had. And we've in all the lessons we've done and everything you've learned in the previous lessons up to this point, we've talked about every single part here. Okay, let's look at number 7. Number 7, let's suppose we had this for number 7. So the number 7. Okay, so we have 4x cubed minus 5x squared plus 8x minus 10. So 4x cubed minus 5x squared plus 4x minus 10. So again, we want to factor this polynomial. Again, look for the GCF. First thing you should do. So if you look at all these 4 terms, the GCF is 1. Okay? Now, how many terms do you have though? That's the next thing you want to do. Ask yourself, how many terms do you see? Well, there are 4 terms. Well, remember, there are 4 terms. We want to try and factor this by grouping. So let's go ahead and in lessons we saw where there were situations where we had to rearrange our terms, okay? But we always try to do this first. We always try to group the first 2 and the last 2 of the original problem. And if that didn't work, then we switch them around. All right, so let's see what we get. So in the first group, I can factor out an x squared. So I get x squared times, and then x squared times 4x is 4x cubed, and then x squared times a negative 5 is a negative 5x squared. In the second group, and you remember, you always factor that middle sign here, so it will be a positive GCF, and the second group, the GCF of the second group is 2, and so I get 2 times 4x is 8x, and then 2 times a negative 5 is a negative 10. And then it should always be, if it is factorable the way we have it, then these 2 groups should have the same binomial factor here. And so all you do now is factor it out, and I get 4x minus 5 times, and then again, when you factor out that 4x minus 5, you're left with x squared plus 2. All right, and then you're done. You can't, and remember, always remember, check to see if you can factor it, if each factor you can factor it further. So if you look at this factor right here, 4x minus 5, the GCF is 1. Okay, and it's a binomial, the GCF is 1. A linear binomial, the GCF is 1. Over here, though, you may say, well, isn't that the sum of 2 squares or the difference of 2 squares? No, it's not the sum of 2 squares, and it's not the difference of 2 squares either. But the GCF here is 1 as well. Okay? All right, so that is the answer to number 7. Okay, number 8, we have negative 18x squared minus 15x plus 9. Okay, so if you look at that one, the GCF, remember it's in descending order, it's in standard form. The leading coefficient is negative, so we're going to factor out a negative GCF. And in this case, it looks like the GCF is a negative 3. All right, so I'm going to go ahead and factor out a negative 3. And so I get negative 3 times 6x squared is a negative 18x squared. And negative 3 times a positive 5x is a negative 15x. A negative 3 times a negative 3 is a positive 9. Okay? And so then again, remember, you always go back and you see if you can factor this further. So I'm going to rewrite this, 6x squared plus 5x minus 3, and let's see what we get. So let's go to the two binomials. Okay, so the factors of 6, there are two possibilities, 6 and 1, 3 and 2. Let's try 3x and 2x first. All right, and then now remember the last sign's negative, so that means one's positive, one's negative. And let's look at the absolute value of negative 3, which is 3. Now 3 is prime, right? So there's only one possibility, 3 and 1. Now remember, are you going to put the 3 here? No, because if you put the 3 here, remember you can factor out a 3, which means that each of these are divisible by 3, and 5 is not divisible by 3. So if you're going to use 3x and 2x, then the 3 has to go here, and the 1 will have to go there. All right, now just because you fill this in, you got to check. Doesn't mean it's correct. You just fill some stuff in. Hence the idea of that trial and error. Okay. All right. So the outer is negative 9x. The inner is 2x. When you add them up, you get negative 7x, and that's not what you wanted. So that didn't help. Okay. So and then if you switch the 3 and the 1, again, that's not going to help because then this is, you can factor out a 3 here, which means that every term here is divisible by 3. So then let's try, instead of 3x and 2x, let's try 6x and x. Okay, see what happens. So 6x plus minus. So this time notice that again, I can't put the 3 here because if I put a 3 here, then I can factor out a 3. And again, we know that can't happen because this is not divisible by 3. So that means the 3 has to go here, the 1 has to go here. So let's check it. The outer is a negative 18x, the inner is a positive 1x. When I add them up, I get a negative 17x. And again, that's not what you wanted. And even if you switch the signs, it's not going to help either. All that does is just make it a positive 17x instead. So I've exhausted all possibilities. That means that this right here cannot be factored. Okay? Now be careful. When some students, and remember we had the discussion previously in our lessons, when some students get to that point, they forget about what they've done already, and they think, okay, well the answer is prime, and they put prime as the answer. No, it's not prime. This right here is prime. You cannot factor, but that wasn't the original. The original was this, and you did factor that. This is it. Remember, factoring means to write it as a product of factors. You have your factors. There are two factors for this problem. Your factors are negative 3 is the first one, and this trinomial is the second one. So there's your answer. All right, so be careful. Don't say it's prime when this is prime, but you did factor the original. This is one factor. This is the other. Okay, number 9. Number 9, let's suppose we had 12m squared plus 28m cubed. So 12mn squared plus 28m cubed. All right, so the GCF, it looks like the GCF is going to be a 4 and an m. Okay, 4m, so the GCF is 4m. So first thing you always do is look for the GCF. And so then I can factor out a 4m, so I get 4m times 3n squared, right? Plus 4 times 7 is 28, and then m times m squared is 28 m cubed, okay? All right, now, so if you look at this, this right here, the 3n squared plus 7m squared, can you do anything to this? You have two terms, right? You have two terms. There's a plus sign here, so is it the sum of two squares, sum of two cubes? It's obviously not the sum of two cubes. For one thing, your exponents are not cubes. And then even if this, and it's not the sum of two squares either, because 3 is not a perfect square and 7 is not a perfect square. Even if it was, remember the sum of two squares you cannot factor. All right, but that's not the sum of two squares. You just can't do anything with it. It's just a binomial that cannot be factored. So there's your answer. You're done. Okay? All right, number 10, we have 12x squared minus 60x plus 75. So 12x squared minus 60x plus 75. All right, so let's look for the GCF. There is a GCF other than 1, and the GCF here looks like it's 3. So the GCF is 3. And so I'm going to go ahead and factor out a 3. So I get 3 times 4x squared minus 20x, 3 times a negative 20x and negative 60x, and then plus 25. Okay? All right, so let's see if I can factor this. So I get 4x squared minus 20x plus 25. Okay, at that point, many students will do this. They'll just go ahead and try and factor this using trial and error. But here's my question to you, though. Before you do that, is this a perfect square trinomial? In other words, will these two factors be identical? And I want you to think about that without using trial and error. Will it? Well, notice that, see this 4x squared? I can write that as an expression squared, and so is this one, 25. In other words, that 4x squared is 2x to the second power, and then that 25 is 5 to the second power, right? And then all you do is multiply these two together. What's 2x times 5? 10x, and then double it, you get this. So is this a perfect square trinomial? Yes, it is. So what that means is this. What that means is the first binomial I'm going to write as 2x minus 5. The minus because of the middle sign. And the second one's the same thing also. Okay, so that this was a perfect square trinomial. Perfect square trinomial. All right. So when you have a perfect square trinomial, that's the characteristics of a perfect square trinomial. So your first term, if it's in descending order, the first term you can always write as an expression squared, and same thing for the last. And if you multiply what's inside those parentheses together and double it, you get the middle term. Okay? All right. And so therefore the answer is going to be 3 times 2x minus 5 squared. Or if you want to, you can write it as just to let you know, you can write it as 3 times 2x minus 5 times 2x minus 5. Does not matter. Okay? All right, so that's number 10. Okay, let's look at number 11. Number 11, we have 64 a to the 6 times b minus 9 a to the 4th power times b cubed. Okay, so 64 a to the 6 times b minus 9 a to the 4th times b cubed. Okay, so obviously there's a GCF here because there are a's and b's in both terms. But for 64 and 9, the greatest common factor of 64 and 9 is 1. So it looks like the GCF then is only going to be a to the 4th. Remember, you always take out the one with the smallest exponent, and then b. So a to the 4th times b. All right, so I'm going to go ahead and factor out a to the 4th times b. And when I do that, and I use bracket. I could use parentheses if I want to. It doesn't matter. But so I get 64. So a to the 4th, if I factor out a to the 4th times b, so I factor out the b, so that's gone. And so a to the 4th times a squared is a to the 6th, right? Okay, minus 9. And then notice that if I factor out the 8th to the 4th, so that takes care of all of these. And then I'm only factoring out one factor of b. There are 3 of them, so how many are left? 2. Okay, now go off to the side and see if you can do anything with this. So I have 64a squared minus 9b squared. So look at this. How many terms do you have? You have 2 terms. So if I have 2 terms, notice the middle sign is a difference, right? So is that the difference of 2 squares or the difference of 2 cubes? So remember, that's where we're at. So is that the difference of 2 squares or the difference of 2 cubes? Well, the exponents are 2, right? And so let's see if it's a difference of 2 squares. If it's a difference of 2 squares, then I can fill this part in. So what times itself is 64a squared? Well, that's 8a. And what times itself is 9b squared? Well, that's 3b. So that is the difference of 2 squares. So my f is 8a and my L is 3b. And according to our formula, it's going to be 8a minus 3b times 8a plus 3b. Okay? And that's going to go here. So the answer is going to be a to the 4th times b times 8a minus 3b times 8a plus 3b. Okay? And again, always remember, you're gonna list your monomial factor first. Okay? So if you look at your factors, of the original, 8a plus 3b is one factor, 8a minus 3b is another factor, b is a factor, and a occurs 4 times as a factor. Okay? All right, number 12, we have 18x cubed plus 8x. So 18x cubed plus 8x. Okay, so first of all, look for GCF. So obviously you see there's a GCF here other than 1. It looks like it's a 2x. So the GCF here is 2x. So I'm going to factor out a 2x. And when I do that, 2x times 9x squared is 18x cubed. And 2x times 4 is 8x. Okay, so I go off to the side and I figure out if I can factor 9x squared plus 4. Okay, well notice that this is two terms, and notice that this is a sum of two squares. Okay, but remember the sum of two squares you cannot factor. So this sum of two squares because I can fill in these parentheses. 3x times itself is 9x squared, and 2 times itself is 4. So this is the sum of two squares. But remember, the sum of two squares cannot be factored. So you're done. This is it. There's your answer. Okay? So you factored the original problem. In fact, you factored it as 3 factors. A factor of 2, a factor of x, and your third factor is this binomial. 13, we have x to the 4th minus 81. X to the 4th minus 81. All right, now this is going to be a little bit more challenging for us. So let's think about this. So you have the GCF here is 1, okay? But you have two terms, right? So let's see if it's one of these right here. So notice that this right here is a 4, okay? So you know that this is not going to be the difference of two cubes, right? Because 3 does not go into 4 evenly. So that is not the difference of two cubes. So then you ask yourself, well, is it going to be the difference of two squares? Okay, well, let's check. Let's see if this is the difference of two squares. If it is the difference of two squares, then that means I can fill in these parentheses. And so you always want to do that. You always want to write this out so that way you can be very careful with your approach. You can think about your approach. So let's start with the 81. What times itself twice is 81? Well, that's 9. So I filled that part in. Okay, what times itself twice is x to the 4th? What expression times itself is x to the 4th? Oh, x squared, right? Because x squared times x squared is x to the 4th. So this is the difference of two squares. So that is the difference of two squares. So here's my f, and here's my l. So then what that means then, I can factor this as x squared minus 9 times x squared plus 9. Okay, so that's where I'm at. But here's the situation. And by the way, if you were to follow it out, x squared times x squared is x to the 4th. A negative 9 times a positive 9 is a negative 81. And the outer is 9x squared. The inner is a negative 9x squared. So those add up to be 0. But here's the problem. If you leave it like this, you didn't factor completely. So remember, you have to factor completely. So you need to check each factor to see if you can factor it further. So if I look at this one here, that is the sum of two squares, and we know the sum of two squares cannot be factored further. But this is still the difference of two squares. So it means I can factor this further. I get x minus 3 times x plus 3. That's what this one is, right? Times, and then this one, x squared plus 9. So that is your answer. So you got to remember, you must factor completely. You must factor completely. And so that's where you're going to check each factor to see if you can factor it further. Okay. And then finally, let's look at number 14. So this is 14. So in 14, we have x cubed plus 3x squared minus 16x minus 48. All right. So the polynomial, the GCF is 1, but how many terms do you have? You have 4 terms. And so when you have 4 terms, remember you want to see if you can factor this by grouping. So let's go ahead and group the first 2 and the last 2 and see what happens. It may be I may need to switch the terms. But in the first group, it looks like I can factor out an x squared. And so I get x squared times x plus 3. X squared times x is x cubed. And then x squared times 3 is 3x squared. In the second group, remember, always factor out that sign here. So we have negative GCF, and it looks like that is what, 16? Okay, and so a negative 16 times x is a negative 16x, and a negative 16 times a positive 3 is a negative 48. And so now notice now, those two groups, they have that x plus 3 as a common factor, so I can factor that out. And so when I do that, I get x plus 3 times, and remember, when you factor x plus 3, you get x squared minus 16. Okay, now here's my question to you. Are you done? Is that your answer? No, very good. That's not the answer. So can I factor anything further? Can I factor this further? No, that's a linear factor, and the GCF is 1. But this, that's the difference of two squares. And so therefore, I can factor this right here as x minus 4 times x plus 4. And then don't forget this is x plus 3. And so that is your answer. Okay? All right, so that is the general strategy. Notice that the thinking process, we went through each of these. All right, so remember, the first thing you should always do is look for the GCF. And then if there are 2 terms, you go through this process. If there are 3 terms, most students will just go directly to trial and error. But I do caution you, I need for you to understand what makes, if it's a perfect square trinomial, what makes it a perfect square? And that's this discussion right here. Okay? And then there are 4 terms. We did grouping, and then always make sure you factor completely. Check to make sure that each factor, just like we did here, if you leave it like this, is not factored completely because of this. That's still the difference of 2 squares. Okay? All right, so that's going to take care of the lesson on the general strategy for factoring.